stars come from? Stars begin from a cloud of dust and gas. These are called nebula. And nebula contract and heat up due to gravity until there's enough heat to begin nuclear fusion. So gravity is really working to pull clouds of dust and gas together, and as those particles begin to collide and hit each other, this produces heat, and as that heat continues to increase, it starts the process of nuclear fusion. We'll get back to that in a second. So this is what a nebula could look like. All right, so a nebula is a cloud of dust and gas, and from that nebula, under heat and pressure from gravity, we get a protostar. Now, a protostar is a spherical object. You could see it in the center there, with rings of material outside of it. As that spherical shape in the center begins to build and grow, what's left over, what doesn't get sucked into that spherical shape, makes up those outer layers, those outer rings. Eventually, when the star is born, when the star is fully functional and fully formed, all that extra material gets pushed out into space. And that's what goes on to make up planets, asteroids, comets, moons, and other things in our solar system. Really, all the material that makes up our solar system came from the formation when the sun was created. That process liberated, freed up materials to form the rest of the solar system. So that distinguishing factor that makes stars so special to be able to create their own energy is a unique process. Stars create their energy from nuclear fusion, and only do so under intense heat and pressure. Nuclear fusion is a reaction taking place at the core of the sun, or any star. What happens in nuclear fusion is intense heat and pressure inside the star causes lighter elements to fuse together to form heavier elements. So in the case of our sun, the lighter element is hydrogen, and it's fused together with another hydrogen atom to form helium. It would look something like this. So here are two hydrogen atoms, and inside the core of the sun, they are fused together to release energy in the form of light and heat and an atom of helium. So because the sun is so big, it has a lot of hydrogen, and it uses that hydrogen as a fuel source to generate light and heat, and at the same time, helium. So our sun is storing up the helium that it's making every time hydrogen atoms collide. In general, all stars use this formula. Lighter elements plus lighter elements give way to heavier elements. Hydrogen is a very common fuel source among stars because it's the most plentiful element in the universe. So a lot of stars rely on hydrogen. Each fusion reaction is going to release heat and energy. And that heat is what we feel when the sun is shining on us, but also the light is a form of energy that's created. Consider the distance between the sun and the planets like Neptune. Neptune's over 2 billion miles away from the sun, yet it's still warmed up by the sun. All right, the total energy that's produced by the sun every second is equivalent to 100 billion times the energy produced from the detonation of a nuclear bomb. So when our sun is fusing hydrogen, it's creating helium. That's the reaction taking place in our sun. But not all stars are doing that. It really depends on how old the star is, how big the star is. Those factors do play a role in what's going on inside the star. But in the case of our sun, eventually it will use all of that fuel, all that hydrogen that it has, it will use it up. And what will be left is just helium. And it will start to fuse the atoms of helium together to form atoms of carbon. And that's going to take more pressure and more heat in order to get helium to form carbon. Eventually, all that helium will run out, and now carbon will be the only fuel source, and carbon will start to be fused together to form oxygen. And then if oxygen is the only fuel source, we're left with neon after fusion. And then if neon is the only fuel source, we'll start to form silicon. And then if silicon is the only fuel source, eventually it will form iron. When a star gets to the point of only having iron as its fuel source, that's really the final stage. As I said, there's no temperatures that exist to fuse it into something else. So at that point, stars usually fall apart and explode in really spectacular fashion, like a supernova. And all of that material that's found in that star, all of the atoms that have been fused together over time, get released out. And that's what builds solar systems. And that's why on our planet, we find elements like the ones shown here, because a long time ago a star exploded and released all these elements out into space. What you're about to watch is a short clip about nuclear fusion. Thanks for watching.